So, good day everyone. Today I'm going to discuss about the chapter 4 of the attached reading, and it talks about the historical changes in the Philippine climate. But before that, a brief recap of what was discussed last meeting, and although I was not around, I was able to read the whole chapter and come up with this summary. So, the previous chapter talks about the Philippine climate, and the said discussion highlights the key climatic features and are the major drivers of climate variability in the Philippines. And examples of which are, as what is shown in the figure. I guess you can identify what was the topic or the said factor. So first, we have the rainfall, wherein the 4 climate types using the modified Coronas classification is introduced. Next, we also learned about the monsoon, which is or wherein the southwest monsoon and the northeast monsoon, or locally known as Habagat or Amihan respectively. And we also know about the tropical cyclones and that it is characterized by strong winds and heavy rainfall and its destructive impacts to the country. Lastly, we learned about the large-scale oscillations, and in there it is composed, or we've discussed ENSO, or the El Nino Southern Oscillation, the Pacific Decadal Oscillation, and also the Madden-Julian Oscillation. And under ENSO, we learned that it has the cold phase and warm phase, namely La Nina and El Nino respectively. So, going back to my topic, which is the historical changes in the Philippine climate, I'm going to discuss the trends and data over the years sa yung mga factors na i-discuss sa chapter 3, which are temperature, rainfall, tropical cyclones, and wind patterns. Excuse me. So, sa temperature, trends and changes in temperature, I've learned about the temperature anomaly, and it is described as the deviations from a reference temperature which are used to compare changes over time. And also, in this, my 2 types of temperature anomaly, which is the positive anomaly and negative anomaly. And the positive anomaly is defined as, or those temperatures na higher than the reference point, while negative anomaly is yung recorded temperatures na lower than the reference point. And sa pag-identify nun, which is here, ito is an example of the data, the analysis of temperature trends from 1951 to 2010 shows an increase of 0.65 degrees Celsius in annual mean temperatures. So, in this figure, this is about the annual mean temperature anomalies from 1971 to 2000, mean value for the period 1951 to 2010 in the Philippines. So, as you can see, in the figure, before 1987, so, di ba may yellow line, so sa left before, syempre. So, before 1987, negative, di ba, pababa yung ano, so a negative yung mga violet. So, yung maka-observe ng negative temperature anomaly, and beyond that is positive temperature anomaly. And also, it has a larger rate of increase over time relative to the overall trend. However, sa positive anomaly, we can still, or trends or downward trends can still be observed from 1989 to 1996 as highlighted by this yellow bar or yellow rectangle. And also, this means that the interannual variations in the warmer period are still evident. Also, as you can see in the figure, the highest positive anomaly happened in year 1998 as indicated by the orange bar. Sorry. And this is quite controversial. I mean, this is considered to be the one of the most significant El Nino events in the equatorial Pacific, which caused a widespread drought in the Philippines. But it didn't just affect the Philippines because it affected the whole world as well. So, actually, it is the 1997 or 1998 El Nino, and yun nga, considered as, diba, as in the headline, El Nino noong 1997 to 1998, pinakamalala sa kasaysayan. And because of that, parang such phenomenon is very popular kasi, yun nga, pinakamalakas. And kung if there are reportings or parang sa news good, if ibalita about El Nino, parang ginagawa siyang reference to show how intense the El Nino is. So, like for example, 2015 El Nino may be worse than 1997 to 1998 episode, says Pag-asa. So, and these are some of the headlines from different parts of the world. So, next is this. Okay, so this figure shows the diurnal maximum temperature from 1951 to 2012, and the deviation from the 1971 to 2000 normal varies over the entire period from positive to negative with a rising trend in 1987. Yun, kagaya kanina. So, falling down to below zero in 1995 to 1996, and 2008 to 2009. So, an increasing trend is noted in the, so as you can see in the blue line, so an increasing trend is noted in the 5-year linear running mean. And also, an increase of 0.36 degrees Celsius has been observed in the mean annual maximum temperature over the 60-year period. So, another data shows the annual minimum temperature anomalies from 1971 to 2000 mean value for the period 1951 to 2010 in the Philippines. So, same with figure 1, negative temperature anomalies were observed before 1987 and positive increasing anomalies thereafter with the highest level of 0.9 yung sa 1998 El Nino. So, an increase of 1 degree Celsius over the 60 period is seen. Diba? Kanina, mga 0.36. So, ngayon naging 1 degree Celsius na, which is 3 times greater than the increase in maximum temperatures. So, the large increase in the minimum temperatures over the observed period indicates that nights are becoming warmer in the Philippines, demonstrating reduced variability and increased convergence of daytime and nocturnal temperatures. So, next is the extreme daily temperature indices. So, analysis of extreme daily temperature from 1951 to 2008 showed some statistically significant trends. So, in this data, parang may data sila sa hot days and cold nights. So, first, is sa hot days. So, kapag sinabing hot days, sa study na ito, it means that, or it refers to the days with maximum temperature above the mean 99th percentile. So, yung red or blue triangles, meaning maklaro, or so yung blue triangles significantly decreasing, and red significantly increasing, then yung negative and positive, yung blue negative, so means decreasing, and positive increasing. So, as you can see in the map, parang covered siya with red triangles. So, in the figure on the left, you can see that there are more red triangles. So, this goes to show that the trends in the number of hot days is significantly increasing in most parts of the country and significantly decreasing in some areas of the Bicol region, Visayas, and Mindanao. So, next is the cold nights. So, same pa rin yung legend, but as you can see, there are more blue triangles, so which are noted in most areas all over the country. This means that the number of cold nights in many areas of the Philippines during the period 1951 to 2008 decreased relative to the normal values for the period 1971 to 2000. However, a few places like Iba and Dagupan in the main island of Luzon exhibit significant increasing trends. So, itong dalawang red triangles. So, these extreme daily temperature trends are found to be spatially coherent throughout the country, according to Cinco et al. And the statistically significant trends in extreme events, as well as the observed mean trends, indicate the recent warming of the climate in the Philippines. So, was na sa temperature, and now we go to lesson 4.2, which talks about rainfall. So, rainfall, as indicated in Chapter 3, rainfall is a major driver of climate variability in the Philippines. So, it is influenced by synoptic systems like monsoons and ENSO, and also some mesoscale processes. So, there is a high temporal and spatial variability of rainfall in the Philippines. However, there are diverging conclusions concerning decadal variability in rainfall, and some say, so these sources, the Jose et al. Observed that increasing trend in both seasonal and annual total rainfall during 1951 to 1992 in the northwestern section of the Philippines, while Cruz et al. Observed or used rainfall data from 1961 to 2010 and showed a drying trend over the same region. However, si Hilario et al., iba din yung conclusion niya, and more on sa floods. So, remarkable floods were experienced in the country in the 1960s, 1970s, and 2000s, and that several drought events were also recorded in the 1980s and 1990s. So, parang malayo gud sa isa't isa yung mga observation nila, and this gives parang further conclusion na need pa talaga i-study yung mga rainfall data sa Philippines. So, next is, so, yun nga, rainfall is a major driver of climate variability in the Philippines. So, ENSO events have greatly influenced seasonal interannual rainfall over the country. And yun, ang na-observe kay kapag El Nino, maka-experience ng drought, and kapag La Nina, maka-experience ng heavy rainfall. So, heavy rainfall associated with enhanced monsoons during these ENSO events resulted in floods and landslides. And also, may nag-study, so, sa table na makita nyo, La Nina events, so higher intensities are indicated by more negative values of the Oceanic Nino Index or the ONI, and yun, nagkuha sila ng 9 out of 12 La Nina events were recorded along its corresponding, ONI value. So, medyo na-confuse ako kung ano yung ONI value. So, NOAA considered El Nino. So, ito pala ang meaning niya. So, kapag ang ONI value is positive 0.5 or higher, ano siya, El Nino. However, if it is negative 0.5 or lower, yun, La Nina. So, I didn't know how to interpret the table. Parang hindi ko wala ding gisabi dun sa PDF. So, yun lang pala na. Ito yung mga recorded La Nina events. And another study is, ito, yung mga onset date statistics for all stations and stations group using different classification. So, ito, may number of stations, regions, number of stations, then the 25th, 50th, and 75th percentiles of station average onset date. So, ano yung onset date? Nag-ask din ako sa sarili ko. So, in the said study, the onset date is defined as the first wet day of a 5-day period receiving at least 40 mm without any 15 dry spell, or receiving less than 5 mm in the 30 days following the start of that period. So, from here, the median onset date varies according to station location, ranging between April 5 to June 26 across the 76 stations used in the analysis. Also, as you can see, there is an earlier occurrence of more than 15 days in the east with type 2 climate than in the west with type 1 climate. Then, the figure on the right, parang nag-show lang siya nung mga 4 types ng climate, and as sabi dun sa PDF that the onset date can also vary according to elevation, such that stations at higher elevation tend to have earlier onset than in the lowlands, likely due to orographic enhancement of convection. And in the figure on the right, stations along the western coast and the inner islands of the central Philippines tends to have the latest onset dates due to its location, either on relatively flat area or on rain-shadowed areas. Then, the onset occurs across western Philippines around mid-May on average, whereas it is indicated as a seasonal increase in rainfall over eastern Philippines around mid-May on average. So, the signal of the onset date is found to be stronger over the central Philippines, roughly from southern Luzon to northern Mindanao. So, yun yung mga nasa table. Next is the floods and droughts. So, floods in the Philippines are usually due to monsoon surges and slow-moving tropical cyclones in the PAR or the Philippine Area of Responsibility. And this is the recorded worst flood years. So, parang 2 sets of data man yun, pero giisa ko na lang. And the first is 1924, 1964, up until 1975. Pero yung updated na data ng worst flood years includes 2000 to 2006. So, 2000, 2001, and to 2006. So, one of the most recent flooding events was caused by Typhoon Ondoy. Typhoon Ondoy brought the worst rainfall to Metro Manila on record on September 26, 2009, submerging approximately 80% of the nation's capital. nation's capital. On that day, maximum 24-hour rainfall of 455 mm was recorded at the Science Garden Observation Station. So, ito yung map of flooding range of Typhoon Ketsana. Yun yung parang international na tawag kay Typhoon Ondoy over the Philippines using data from NASA's TRMM satellite. So, next is drought. So, drought happens when precipitation is lower than expected and insufficient to meet the demands of society and the environment, lasting over a long period of time. So, ito yung list ng or significant drought events in the Philippines during 1968 to 1999. So, the most significant drought event occurred in 1982 to 1983, then 1986 to 1987, and 1997 to 1998 as highlighted in the table. And they were associated with El Nino events, but the drought in 1989 to 1990 occurred during a neutral condition. So, ito yung mga records. So, sa 1982 to 1983, Western and areas affected, ito sa Central Luzon, Tagalog provinces, Northern Visayas, Bohol, and Western Mindanao. So, moderate to severe drought affected most of Luzon, Negros Occidental, and Iloilo. Damages, total loss of 6.4 times 10 to -5 of rice and corn. Insurance claim amounted to 38 million, and hydropower generation loss was 316 million. So, same din sa 1986, may mga agricultural damages amounting to 47 million, and yun din sa hydro energy generation, 671 million. So, next is, ito, sa climate extreme. So, gi-analyze yung extreme intensity and extreme frequency. So, analysis of extreme daily rainfall intensity or the amount of rainfall above the top 4 events during the year. So, as you can see, the figure on the right, it shows an increasing trend during the period 1951 to shows the frequency of extreme daily rainfall indicated by the number of days with rainfall values greater than the top 4 events during the year. So, diba wala man masyadong significant increasing or decreasing. It's mostly positive lang na naga-increase. So, most of the stations in the country shows an increasing trend in the number of days of extreme rainfall events. And however, a few stations, may mga red and mga blue. So, like sa Tacloban and Iloilo, significantly increases, and sa Coron and Kuya naman sa Luzon, it shows a significant decrease in the frequency of intense daily rainfall. However, majority of the stations do not show a high level of statistical significance or at the 95% probability level, and a high level of variability is seen in these stations. Same din sa frequency. So, next is the extreme monsoon performance. So, yan. So, itong enhanced southwest monsoon or habagat on August 6 to 8 to 2012 is the most, or considered as the most notable extreme event. And it caused great flooding in Metro Manila, but not just in Metro Manila, but as well as the nearby provinces. Sa nabasa ko, it included regions in Calabarzon and Central Luzon, and caused damage to infrastructure amounting to 639 million, damages to agriculture 1.6 billion, and caused the death of 95 persons. And in this said phenomenon, naka-affect din siya ng 800,000 families, and they were left homeless. So, August 6 to 8, 2012, here is the daily rainfall data. So, sa August 6, 323.4 mm, August 7, 391.4 mm, August 8, 292.6 mm, and a total of 1,007.4 millimeters yung na-record. And kapag i-compare mo siya sa normal lang na monthly rainfall is 504.2 lang. So, it's sa 3 days na yon, twice as much na yung rainfall. And yun, grabe talaga ang naranasan, and here is some of its images I got from Google. So, actually, this event is commonly known as the Hagupit ng Habagat. Yun yung nasa mga headlines. And also, sa nabasa ko from other sources sa mga news, it didn't only last for 3 days. Actually, it started in July 2012, or parang last week ng July to first week ng August. And etong na-record lang is yung, yun nga, extreme monsoon performance, kasi ito yung mga peak lang or yung mga mas malaking values ng daily rainfall data na nakuha. So, next is the tropical cyclones. So, tropical cyclones, the Philippines belong in the Ring of Fire. So, it is found in the western part of the Pacific, and also sa makita nyo, excuse me pa. So it's important to highlight the location of the Philippines because 1/3 of the world's tropical cyclone developed in the western North Pacific. And from 1951 to 2013, 1,220 tropical cyclones entered the Philippine area of responsibility. Wait ako, sorry.